So hello everybody. So today we want to talk about the topic differentials. So the first topic is tangent line approximation. Okay, then I want just to discuss what this means here. Okay, so you know that tangent line means whenever you have any object here, then it passes through just one point here, right? Something like that. Okay, so let's say this is maybe A, and then FA here. Okay, then first of all, we can using the differentiation and create that tangent line equations, right? Okay, so let's say we construct that y equal to mx plus b from here. Okay, then based on this, now we can just approximate the dependent value based on very close to x value here, such as maybe now this point, it can be really tiny bit bigger than a. This one is a little bit less than a, like that. So I'm going to show the table later, but based on that tangent line equation, we can approximate very close value outcome value basically. Of course, it is not accurate though. We just guess, just approximate the value. That's it. Okay. So as you see the formula here, so we can make y minus fc equal to f prime c and the x minus c here. So simply, this is the slope of the tangent line, right? Okay. So we know the slope and the point C and FC. So this formula basically we used point slope formula. After all, you can find out this formula here. Make sense? Okay. So when we look at the example, then it can be much more clear. So let's discuss one example together. So example 1, using a tangent line approximation. So find the tangent line approximation of fx equal to 1 plus sine x at the point 0 and 1. Then use a table to compare the y value of the linear function with those of fx on an open interval containing x equal to 0. Okay, so remember, open interval, that's the key point here. Okay, alright, so first step is we want to find out tangent line equation. So we need to find out derivative of that given function. So f prime x becomes cosine x, right? Yeah, because 1 just becomes 0, and then derivative sin x become cosine x. Now, plugging 0 to here, why? Because we want to find out tangent line slope at the point. That's the reason. So, f prime 0, which means cosine 0 equal to 1. So, we found the slope equal to 1. Therefore, f prime 0 equal to 1 and the given point 0, 1. So we can find the tangent line equation. So let's do so. So y minus 1 equal to 1 times x minus 0. Therefore, y equal to x plus 1. Now let's approximate the near x value about the outcome here. So we know that this is the basically approximation of the linear function. So centering on x equals 0. So I'm gonna put 0 here. Maybe just put 0, 1, and then 0, no, actually it's much closer than that. So 0, 0, 0, 1 and 0, 0, 0, 1, 0, 0, 1 like this, and then negative 0.0001 and negative 0.001. Okay, So now you just plug those value, this value into all here. Then let's figure out what we got, the output value here. Okay, so I'm gonna just pause this video and then just calculate it, and then I will get back to you soon. Okay, then you will get these values. Then are those values reflecting the actual outcome value? So what I want to do, just input this chosen testing x value into the original function here, also get the answer. Okay, so the same thing, I will get back to you really soon. So when I do that, I got really close to one value here. So even though my approximation, this value is much closer to original value 1. So what I want to do, I'm gonna make a little bit further, like a 0.1 and then 1.5, something like that. So I'm gonna just complete this table and then I'll come back to you soon. Okay. So I chose little further values such as a 0.1. Oops, we can see, so I'm gonna delete it. So like 0.1 and then 0.5 and negative 0.1, negative 0.5. So when I plug those value into the our tangent line equation, I got 0.5, 0.9, 1.1 and 1.5 here. And then this value are, I plug all this x value into this original function. I also got very similar outcome value like a 0.521, 0.9002, and then 1.099, and then 1.479, like that. So sometimes instead using original function, so you want to find out the y value based on given tangent line equation, then using tangent line equation may be a little bit simpler and easier. And also this is another way to approximate the closer x value to values outcome value. Okay, then let's extend this concept a little bit further. So we just talk about differentials this time. Okay, so you know that derivative format or notation, we can write dy over dx. The another notation is f prime x. Okay, so from here, so when we separate dy and dx value, then based on this format here, we can write dy equal to f prime x times dx. Do you see that? Okay, so now it means the given we have a derivative function, and then if we know like the value of dx, then we can find out dy value. Basically, we talk about like optimism problem. It's similar like that. So we want to find out basically dy or dx value based on given data value. So that's kind of differential here. So look at this table. Then so let y equal to fx represent a function that is differentiable on an open interval containing x. Then we can find out dy equal to f prime x times dx. So look at one question and then maybe discuss one example problem. Comparing delta y and dy. So let y equal to x squared, find dy when x equal to 1 and dx equal to 0.01. Compare this value with delta y for x equal to 1 and delta x equal to 0.01 here. Okay, so we will do dy part first, and then later on we can find out delta y as well. So find out dy, then we can derivative this one. So dy over dx equal to 2x, right? Okay, after that, then we can rewrite this dy equal to 2x times dx. You know what I did here, right? And now just to input all the known value. So x equal to 1, so x equal to 1 into here, and dx value into here. Then dy equal to 2 times 1 times 0.01. So you calculate that, you will get 0.002. Okay, then let's find out delta y. Okay, so basically delta y case, you can do f x plus delta x minus f x, right? Okay, then now from the original function y equal to x squared, I'm gonna find out f1 plus 0.01 and then f1 here. Okay, so which means f1.01 and then f1 becomes 1, f01 equals 1.01 square, so you calculate it and become 1.0201 here. Therefore delta y, we can do this value minus this value, so 1.0201 minus 1 equal to 0.0201. So when you compare this value and this, oops, I made one mistake here. Okay, so sorry, that should be 0.02. So let's compare. So we got dy equal to 0.02 and delta y equal to 0.0201. So as you see, so dy value is really similar to delta y value. Okay, so that's all today. Okay, thank you.